That's gonna be just like with a real sander. You want to continue?
You want me to do it?
Yeah.
Sure.
Have a cheeseburger.
Can you go to the other side so I don't see your back? There you go.
Okay.
Cool.
Is that enough footage of that? 'Cause I think
Yeah.
I can-
Drill some holes here, so we'll have 2 holes like so, 2 holes on that side. So this is it's kind of like at this point it's kind of like a picture frame. It'll be like that, and then these 2 will go on top. Does that make sense? Now when you attach pieces of wood together like that, the way to do it is you want to have the flat part. You're going to have a hole where this will slide in and out, and then it's going to bite into that wood. Does that make sense?
That again.
Okay, so I'm going to attach these 2 together like that, right? We want to drill a hole that is as wide as the threads, like we were doing with the bolt earlier. So there'll be a hole that's the width of the threads, and the thread's going to go in and out, and then it's going to bite into this, and so we're not going to drill this side. Okay. Does that make sense? Okay. So what we need to do is we need to get a drill bit that is the width of the threads. Okay.
Okay.
There you go. Hold on 1 second. Let me get him set up. Out of juice?
Yep.
Okay. Okay. So now, so the screws will go for each of these, like so. Then what you can do is you can line these up and just kind of get the. So I'm getting this flush and that flush, and now it's dented the wood just enough so that it will hold it in place, and then you can just kind of screw down. Want to screw while I hold it? Sure. Let's just step over here so she can get your face in there. Get it lined up. Let's do this. We have the torque setting really high on here. What I don't want to have happen is I don't want to have the drill head get I don't want it to get messed up so that we can't tighten it. So when you're doing, instead of just holding it down, feather the drill, so you're just kind of pushing and going down. Okay, that makes sense? There you go, that's good. I'm just now realizing I think we messed this up. Yep.
This one actually works pretty good.
So do another one just in that other corner.
What was my lead doing? Try.
You're saying he did all the work?
No, not all of it, but he did a lot.
Good deal. All right, Dallas, come on over. Here's what we're gonna do. We're gonna have you drill. All right, so this is, we're gonna attach those two together, so that's gonna go in like so. When you're drilling, don't just squeeze down. You want to go relatively slow. What I find works the best is to hold it and kind of squeeze and then let it come up. So just move it relatively slowly. That make sense? Okay. Here we go. Try to hold these up to the. I can hold it there if you want. So push and squeeze. Just push down. Perfect. Go, do another one. Hold the board with your left hand. Go just a little bit more. Get it all the way flush. Perfect. Okay. Guys, we're going to need another. I don't know. Good. And same with that other hole. That's all right. It's splitting a little bit. It'll be fine.
Is it okay to do it like that?
It's fine. Just go straight down.
Like all the way through?
Push a little harder. Yep. There you go. That's it. Okay. All right, now we need to get this slightly smaller one.
This one?
Yep. Okay, so these are going to be the guide holes here. You're going to, we might want to do more than that. One second, let me think here. Let me set this up. Excellent. Okay, and so because we're going to use a longer spoon, what I want to do is I want to find a drill bit that is as wide as this, not as long as this. So the way that I tend to do this is, yes, give me just 1 second. Let me. You absolutely can. Let me just get this one started because I want to line something up.
It's great living with a bunch of mechanics.
All right, so here's what we're gonna do next. tip sticking like so. So they do fit. Okay, where these two dots are, we're going to use. Yeah. Just go nice and slow.
Well, eyes protection and hearing protection.
Here.
Thank you. Do I need ear protection?
Not for drilling, I wouldn't think.
Just try to go nice and plump.
It's good?
Go all the way down. Pull up. Now, use this drill. Go nice and slow. So feather it. So don't just squeeze the trigger. Kind of squeeze and let go. And so it's just going to go in kind of go a quarter inch at a time.
Okay.
Push down so it doesn't strip the. Try to put it down the floor.
I think we can do it.
Push down on the top of this.
Yeah.
That's good. Okay.
Okay.
Now, all right. So I want you to drill this so that just the tip sticks through, just an eighth of an inch. Should be okay. Push on the back hard. There you go. That's enough. We just want to have just a little bit sticking out the end.
Should
We're
I
going to use
reverse
this.
it?
Yeah,
Or
reverse it. We're going to use this as a mark to identify where to drill the pilot hole for the next one.
is that
A
good?
little bit more. Keep going, keep going, keep going, keep going, keep going. A little more. Right this way.
Is that good? Thank you.
Okay. When you're doing it, push down as you do it. And kind of squeeze and release. Let it go down.
Really, all right.
But really push down. Give it some. There, that was good. So look at the difference in the heads.
Definitely.
So this one, when it's spinning around, it's kind of chopping up that metal.
Yeah.
There you go. All right, who's up? All right, so on the next one, do even less than that. So we noticed that the hole is a little off center, but as long as they're both a little bit off center, so this side is off by, and you can kind of eyeball, you can see it's like an eighth of an inch, it's a small amount. But if we go that way, then they're pretty much lined up. So what we want to do is rotate it like so. Make sense? Okay, so this part we're just gonna. Is there a hammer in that? Maybe the middle drawer. So what happens a lot is that the bit will get clogged up with wood. And so if you kind of go in and then pull out, the wood will fling off and then it'll cut easier. So try pulling up now. All right, now do it one more time and watch how easy it'll go down. Pull the bit up, clear the wood. There you go. Excellent. Right, switch gun. So, all right, screw them down. Push hard. Push. Excellent. All right, there's our frame so far.
I'm staring.
Is that working? Is there enough meat on there to? All right, let's just. Okay, good. That's fine. We're just gonna hold that for now. Let's flip it over and do the other side. Grab that, the one with the 2 holes in it. Yep.
Oh, are you drilling it in?
Right now, I'm just kind of testing this to see how we're doing. You have the other nut? Oh, that's
think
the
it's
wrong
too
one.
big.
Yeah, that was here. Do this one. You want to use 7/16 on that one. That's measured. 7/16. All right, that's good. All right, so even with that other board, we could actually probably do our test without that other board for today. So this thing is designed to sit with our tube in that center there. And then by angling this, we can angle it towards the sun. Does that kind of make sense? Mm-hmm. That answer your question before about how the sun's gonna hit it? Yeah. So the idea, if the tube is sitting inside there, the sun's over here, it's gonna hit the whole length of the tube. And then as the sun moves over, it's now kind of hitting it that way. As the sun's coming over, it's hitting it that way. Right? Okay. I'm actually thinking that we may be able to live without that bottom piece.
I would agree, like an easel, just
Yeah.
simplify.
Yeah, I think why don't we go ahead and do that for now so we can run an experiment with it. I'm thinking that I wanted to just kind of assemble it, make sure. Oh, I'm not worried. You just say don't worry?
No, I said we have 3 people. Don't worry, we don't need anyone else. Ow! Ow!
Splinter?
No, I hit my finger on the table.
Freezing, that's even worse.
I took my gloves out of my pocket yesterday because it was so warm, and I wish I had them in there now.
All right, so here's what I'm thinking we'll do. Jack, why don't you come on over here? Here's one concern. Since we didn't really completely finish off this bottom part, it's entirely possible this will just kind of pull away and the whole thing will just crash to the ground. So
We could put like these.
this
right
won't be a
there.
big. Just hold this so it doesn't do that. Does that make sense?
Okay.
So why don't you come over here? You're gonna you'll be the one in charge of the tube. Oh, you know what I just thought of?
What?
That thing's got it. There's a little nub on the bottom of there. I'm gonna drill a hole in the bottom.
I'm gonna put
Put it in the hole in the bottom.
roll.
Still kind of resting on that.
But I mean, oh yeah, like
You see what I'm talking about?
you tilt it like that. Well, it won't be tilted like that, will it?
Jack, why don't you come on over here and hold?
Okay, I can't. I'm not getting anything. Yeah,
Do you want to move this way a little?
that's good.
All right. So the question here is whether it's going to stick up correctly or not. Are we lined up there?
Yeah.
When you guys grab me that yellow drill? All right, you got the frame?
It's not wiggly, so that's good.
All right. Can you lean it back or is it going to fall out?
No, it's really.
It's in there good. Can you pull that leg down so it touches the ground? Okay. So there we go. There's our little build here. Okay, so the idea with this is that in this position, if the sun is angled right here, the sun ray is gonna come down and it's gonna hit a rectangle on this. If the sun's over here, it's still gonna hit a rectangle. So the sun kind of rolls around this. Does that make sense? And then depending on the season, it would ultimately tilt. And so in the summertime, hopefully I don't break this thing. All right, so in the summertime, the sun is higher in the sky. So the legs would kind of tilt backwards in the summertime. And then in the wintertime, it would be a little bit more vertical because the sun is lower in the sky. All right? So here's my idea for our experiment. We'll take a tea kettle over there. I've got one over in the kitchen back there.
Yeah.
We'll heat up the water to some temperature. It'll say on there maybe 80 degrees Celsius.
Okay.
We'll pour it into this tube, and then we'll put this cap over top, and we'll take a thermometer and we'll measure the temperature of the water. Then we'll just wait. We'll wait 10 minutes, 15 minutes. We'll measure it again and see how much how much heat is lost. And so because there's a vacuum around this, it should be very, very efficient at trapping that heat. But it's not going to be perfect. There's still going to be some heat loss. And so this test will just kind of measure how much energy is lost. Does that make sense? Mm-hmm. Okay. We need to 51 and 78. All right, quickly look at those numbers and everybody tell me the average. What's the average? It's hard, right? So this allows you to do this. We can say average, and you just select the data. Boom, there's your answer. Okay, so this is summing them all up and dividing by the number that you did. But so a spreadsheet allows you to do a bunch of very easy calculations. Like if you wanted to add all of those numbers up, you could do sum, and then do that. It just adds it. Okay, so by using the spreadsheet to just record the temperatures, we can then identify the averages or the sums, or we can plot it on a chart so we can have this down, and then we'll put a thermometer down. We should measure one other thing.
All right.
Do you want more kids in the shot?
Yes, please.
All right, come on over, guys.
Am I in the shot?
I'm not right now. No.
Jack, you're cold.
That's better. Good.
To the emergency room.
Tell me when you're ready.
Good.
All right, so here's what we're gonna do. I've got this tea kettle has got the water. It says it's 212. It's probably somewhere around there, around 100 degrees Celsius. I don't know the exact volume of this tube. So what we'll do is we've got a measuring cup, and it goes up to 250 milliliters. So I'm gonna pour 250 in here, and then hopefully pour the 250 in there without spilling it too much. And then we'll just keep doing that until the water gets to the top. All right, so this is 250. How what?
How full?
From say, I didn't look. Dallas, can you look inside there and see the water or not?
Oh, kind of.
Okay.
Two.
You guys are on camera, so funny as you are, and you're very funny. So.
All right, so that's about the top right there. All right, so we got about 750 milliliters of water. So we'll put this top on there. Now wood's not a great insulator, but it's a pretty good insulator. Shove that in there. Nope. Okay.
Is it on?
All right, you guys read that?
Not particularly.
$6.91. $7.05. $7.15.
7:15.
Just kidding. I can't see.
All right, let's see. Why don't you guys get over on the computer?
I can't see you good.
All right, so it's still climbing.
Your
Which means that
computer
it's
screen started.
shot.
Guys, don't say this stuff while we're on camera, please.
It's not.
It's not on. Okay, so we've got time, water temp, and air temp. So it's starting to equalize.
Time is 2:20.
Okay, so write 220 down.
What is the temperature?
Okay, the water temperature is 85.2 Celsius. And the air temperature is 10.7 Celsius. Wait, hold on, the air temperature is going down. Change that to 10.5. As soon as we stop there. What was the number you had there? 85.2 and 10. All right, so we'll wait for a couple minutes and then we'll measure it again.
5 or 10.
I guess we could just do it every 1 minute. Let's just try it every 1 minute. Why don't you just shout one for the next minute? What's the next?
2:21.
All right, 221. So I've got water temperature is 84.9. Tell me when ready.
Water temperature?
84.8. The air temperature is 9.7. Do
222.
84.5, 9.3.
When you finish giving the calculations, can you then do a summary kind of thing of
Sure.
okay, what your findings were?
Yeah. Tell me when.
Okay. Oh.
Okay. See, the air temperature is still going down, which means the thermometer hasn't even equalized.
$223.
84.2, 9.1. Well, this part of the film won't be very exciting.
We will cut this part.
$2.94.
83.8. 9.0.
Steve,
Yeah.
I think maybe that's a little bit of
Yes,
a new.
absolutely.
He's in very good radar temperature. He
So
doesn't
this
get
is the
any-
water temperature.
Say it out loud too when she gives you the time.
It's a good station.
$2.25.
Read them.
8.34.
83.4.
83.4.
Oh, 83.3 right now.
Okay.
Yeah. Change.
And air temperature?
89.
8.9.
Mm-hmm.
Air temperature keeps going down.
Okay. What's Canada? What's Canada?
You see that? Left alignment. Left aligned it. When you have that letter in there, it treats it as a string. If you got rid of the letter C, it will treat it as a number.
Can I take pictures of this?
Hmm?
I'll take a picture of this before I leave.
Oh, 8.20.
Don't take a picture of what?
I'll take a picture of this before I leave.
Hit the measurement, guys.
Dallas, that's your job, man. Yeah, you're fired. 8:30.
Dallas, do it again. Do it seriously, please.
Sorry, I was just right. 8:29.
A little louder.
8:29.
82.9.
Yeah, exactly.
And the other
Air
one?
temperature.
87. 8.7.
How long are we going to use this for?
I don't know. A couple hours.
Got 45 minutes more of tape on this
That's right.
particular card, and I got a second card too.
You could just show this in high speed.
Yeah.
It's not insulating very well.
That's not a bad idea.
Yeah, it is. It is. Please go down. It's not perfect.
So what does that air temperature translate to in Fahrenheit?
I don't know. 45? Well, let's be Fahrenheit.
Sorry,
Take a
227.
measurement.
8:25.
Are you saying that right?
Yes, I am.
82.5.
82.5.
And the other one?
I don't care. 8.5.
I love this song.
What did it start at? What did the two?
85.2.
85.2.
228.
Measurement, guys.
Jeff, it's your turn.
I can't reach. Dallas, go. I'm too short. Go.
So?
Read it.
8.23.
It's 82.3.
I just said
The other one?
I just said that.
The other one
You
down.
said 8.23.
It's even higher.
8.4. How hard is this?
So you want to do a conclusion after the next one, or what do you think?
We should wait 10 minutes because
Okay.
it's almost 10 minutes
Oh, cool.
after
The
these
only
next
thing, if
two.
you need everybody in the come around, please leave it up. If you leave
Ah.
it, so.
In a minute. I have 1 minute. To laugh.
I'll get another measurement.
It's 2:29.
What are you doing, man? 8.21. 82.1.
And the other one?
8.5.
That one's finally equalized. Okay.
Get a close up on
2:30.
there.
Can I close the?
Just 1 minute. I want to get a close up. I was getting a close up of this. Computer.
Would you turn off?
Okay.
8.8.
81.18.
Yes.
81.
Okay. And the other one?
8.5.
We're done.
Okay, we're done. All right.
So is the blue the tube?
Blue is the tube, yeah.
Cool. Because it looks like the outside temperature is pretty consistent, and the
Well, no. What's kind of interesting is it takes a while for the thermometer to get it kind of an equalized temperature. And so what's actually kind of interesting is it took 10 minutes for the air temperature to basically equalize. You know, it's the air temperature started at 10.5 and it went down to took about maybe 7 minutes to get to 8.5, and then the last 4 minutes or so, it was staying at about 8.5. So what's most likely happening is that's just a reading measurement on the thermometer, you know, a fluctuation in the thermometer itself. And the water temperature, you know, we expected it to go down, and it certainly went down 4 degrees. But to go down 4 degrees over 10 minutes is pretty good. What we can do next time is I'll go over the equations to show the insulating value of this. So we can measure the watts per square meter per Kelvin. So basically the amount of energy that's lost per square meter that's touching the air. You know, because everywhere around here is 8.5 degrees, and inside there it's 10 times hotter. And so it is, you know, it is much hotter inside there, and it will go down, but it's going down slowly. Now, one thing we didn't do in this little experiment is we don't really have a control group. This was really more of just a proof of concept to see if this experiment would in fact work. A control group for this type of setup would be another tube that just had a single layer, maybe no vacuum, that had the same amount of water, and it was in the same 8.5 degree air. And if we had that, then we could compare the two values. But this is a fairly well-known bit of science, and so we can use these numbers and really get some values out of it.